Hello viewers, welcome to my channel. In this video I want to show everyone on how to compute for volume using the surveyor software. However, I'm just quickly going to open my AutoCAD Civil 3D for a quick explanation, a very brief one. So you can actually make use of the Civil 3D for volume computation if you want to compute for the volume of total surface area. But in this case, I want to compute for the volume of a particular section of the surface. So let me just activate the object viewer for better explanation. So there is a particular material field up here, that is a sand, right? So my clients want me to compute the volume of the material. There's a sand heap up within this section so that he can know if it meets what he has actually bought from the buyer. For as many as possible who does not know the application of topographic surveys, this is one of the applications. All right, you can use it to quantify materials, to know what you are buying, to sample some area that is that is deep, to know the quantity of what you want to buy. Okay, so there's a sand field here my client bought, and he wants to know the volume to know if he has not been cheated or not. So this is how to go about it if you want to compute for the volume of a particular material. So first thing on AutoCAD is to make sure that you define the extent of the particular material. So you can see the red boundary line. This is the extent. So you need to use the polyline tool. Make sure you use the polyline tool to define the extent. After you define the extent, you make sure your perimeter is an enclosed object. Alright, so you select the extent of the material, you right click, come to clipboard, copy, then you open a new workspace, then you paste to original coordinates. So this is it here. So after you paste to original coordinates, you make sure you save as DXF. Right, this is how you save as DXF 2007. Then you rename the particular file. So I have renamed it material area. So this is the extent I want to compute for the volume out of the total surface. Right, so you do that. After you do that, then you can minimize your Civil 3D program. Then you launch into your software application. First thing to do on software application, you generate the contour of your surface by coming to contour. Click on contour. Then you can navigate to where you have your graded data, or if you have not interpolated for your graded data, you can now create a contour from your primary data, that is your eastings, northings, and the elevations respectively. So this is my topo data here. Alright, this is for the graded topo surface, and here it is. So after you generate your contour surface, the next thing is to overlay the particular extent you want to compute for the volume. Right, so you select the contour surface, right click, that is your contour that you generated, you right click, scroll down to add to map, then you navigate to base, click on base, then you can now select the DXF perimeter of your extent. So when you select it, you click on open. It's going to ask you all this. Alright, just click on OK. So you can see it overlaid here. So the extent I defined on my AutoCAD Civil 3D, you can see the SR spot is where it has overlaid. Alright, so I can just change the color of that. So I select it, come to color to make it red, to make it different, and the width bit visible. Alright, so you can see I define the extent of the perimeter of my surface, and you can see this is where the heap of sand is. Then the next thing is now to click on the grid tab to navigate to the volume tool. Right, so you select, click on volume. So here on this dialog box, you are going to see upper surface. If you are making use of the Golden Software 2024 or above, you see the grid volume, you see the lower surface, you see options, you see polygon. I'll briefly explain what all this is. Alright, so for your upper surface, this is the primary major topographic surface. Alright, while lower surface is when you are comparing or you are computing for volume between two surfaces, maybe between the finished levels and the existing levels. Existing levels is the direct data the surveyor observe, maybe captured with a drone or the normal conventional GNSS or the total station method of survey. All right, so that is the existing data. That is your primary raw ground surface data, while the lower surface will actually be the designed levels by the engineer to maintain the particular slope within what they have actually designed, or vice versa. All right, so that is for the upper surface and the lower surface. It is used when you are computing volume between two topographic surface, two contour surface. So for these options, aligned grids is when your two set of data does not have the same extent. All right, you make use of that. And the z-scale factor majorly is on default. All right, so leave it on 1. Then this polygon boundary is for an option where you are computing just like what we are about to achieve. This is the particular method where you are computing volume between a surface and a specific extent. All right, so and that is what we are trying to achieve. So I hope we got all that. Therefore, in my subsequent videos, I'm going to take each case scenarios between two different surfaces, within a surface, and so on and so forth. So at this stage, the next thing to do is to click on the drop down here. Then you select your contour surface. All right, we are not making use of this method, so you just scroll down to polygon boundary, click on the drop down, then you select your material area, that is your DXF perimeter. Okay, you select that. Then you are going to see these options activated. Volume inside, so let me just drag this. The two options is volume inside and volume outside. All right, the volume inside is the volume within the extent you have defined, while the volume outside is the volume that is outside of this hole, aside your particular section of interest. So our section of interest is the sand, the heap of sand materials within this particular surface. Therefore, you just click on OK. So you are going to see your volume computed. Just expand this, and here is the computation results. So all of these are just the information you may need. So I'll just quickly go to the information of interest, which is the total volumes. So there are three different computation methods that the Golden software will use to compute your volume. All right, the trapezoidal rule, Simpson's rule, and the last one, which is the Simpson's second rule. So you are going to see the volumes by these three different computation methods. So this is the result, and it is in meter cube. The unit of your volume is in meter cube. So this is it, and you can see for the cut and fill volumes, although this is not really important because we are not doing between two surfaces. When you are doing volume computation between two surfaces, that's when you have the accurate cut and fill volume results. But for this particular exercise, we just compute the volume for, we just quantify the material within the project site, and that is that. So I can actually save this file as the volume of sand for my client. So this is the volume of the material within the defined extent. Okay, and I can make this 3D. So I'm just going to make this 3D for better visualization. So under this 3D surface, I'll select the grid, and alright, so this is it for the 3D surface, and I think I should make it show base for better. Okay, so here above is the heap of sand somewhere. So above here is the heap of sand, right, and that is what I have computed for. So you could see the volume of the materials, my YouTube folder, and volume of sand. Okay, so based on that material, this is the volume in different three computation methods. So also, in case you want to compute for the total surface volume, both for everything, all right, generated the volume within the total surface. So you can see this is by the trapezoidal rule. This is 1,320,982.262 approximately meter cube, and you can see, so this is the total volume of all the surface. So in case you are interested in that, you can make use of that, but I did advise you make use of Civil 3D if you want to compute for the total surface volume. But for a particular section of volume, it's best you make use of the Golden software software. This one is actually best for that. So guys, that is how to compute for volume of materials, okay, using your topographic survey data. If you find this video helpful and informative, do well to hit on the subscribe icon, as well as turn on your notification to keep on getting valuable tutorial freely. In my subsequent video, I'm going to show you the other methods of volume computation for your engineering or topographic surveys. Thank you for watching. See you in the next video.